Yep.
Okay, let's move again to the content. Um, the waves, so easy, I
Yeah,
think.
waves are a lot
Or
of
you
issues.
have any problems in waves?
Waves is my biggest problem. Waves is my biggest problem. I do not
Oh,
like waves. I hate waves.
waves. Whoa,
Yeah.
the easiest topic. I love
Really?
waves.
Oh,
Oscillation, traveling waves, and wave characteristics and wave behavior. That's easy, my friend. No, 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 no.
you find
Waves,
waves very easy. Oh,
where is the problems in waves? Most of students, they
waves.
don't
I
know
just don't understand it.
what
It's like
is the relation.
oscillations and traveling
I
waves, standing waves.
oscillation. So
There's so
I
many
want to
such.
ask you
Yeah,
questions. I want to ask you questions. What
yeah.
is the relation between oscillations and waves? Are there any relation between oscillations and waves, the water
Yeah. The
waves,
more.
and oscillations,
Yeah.
pendulum oscillations? How the oscillations relate to the waves? How?
Um, I'm
I
not
tell
sure.
you,
The more
that's so
oscillations,
easy.
the more waves.
If you want to, yeah, the oscillations will create the waves. If you have a surface of a water, okay, and you will
Okay.
want to make one wave, you will hit the surface of the water.
Uh-huh.
This will make a wave, just one wave. If you want to make traveling wave
Uh-huh.
go after wave after wave after, you must hit the surface of the water and frequency, like oscillation. You must bring
Uh-huh.
like a spring, and the spring will isolate. When the spring go down and hit the water, it will make a wave. Go up, go down, hit the water, make a wave. Go up. This is the oscillations.
Yeah. Okay.
Make the waves. Okay, make the
Right. Okay.
distribution or to make the wave, and the frequency of the oscillator equals the frequency of the wave. Did you understand this
Right.
point? So
Yes. Yeah.
oscillation,
I
the
understood. I
oscillation is
understood it. Yeah.
amazing. Yeah,
Hmm.
so the next topic directly traveling waves. To make traveling waves, you
Uh-huh.
must make uh, an oscillation, make a distribution.
So
How it
traveling. Wait.
makes
Uh,
use
so
oscillator. The
traveling waves
oscillator
does
like
not.
spring, the spring will go up and down with the specific oscillation frequency.
So standing waves does no oscillations.
Yeah, yeah. Standing waves have no oscillations. Are you sure?
Okay. All right. I'm not sure.
So standing
Is it not?
wave, no, standing wave. I will begin with one oscillation. The one oscillation will I will make like a rope or anything or spring. I will make one distribution, will make one oscillation, and it will make one
Uh-huh.
wave. This wave will go and will reflect and get back. When it get back or reflect back again, it will uh, it will make the standing wave. So standing wave will need
Yeah.
oscillation. No distribution for the medium. There is no waves. And
Uh-huh.
no oscillator, no waves. No oscillator, no waves. So if
No
you
waves.
stop
Okay.
oscillating, if the oscillator, if it stop and stop moving up and down or back and forward, the wave will
Yeah.
stop directly. Okay.
Right.
So,
Okay.
for example, the sound wave. How can you listen me? This is the sound waves. My vocal cord here, there is something
Yeah.
vibrate inside me. When it vibrate, it will generate the sound wave. When I stop vibrating this vocal cord inside me, the sound will stop. So vibration,
Uh-huh.
the oscillations is very, very important to make and create the sound. When you hit a drum, this drum, the surface of the drum will vibrate and oscillate. and will create the
Right.
voice
Yeah.
and the sound. When it stops,
Uh-huh.
the sound and the wave, the sound of the wave will stop. And very, very important point. When the source
Uh-huh.
didn't change, the frequency can't change. The frequency depend on the source. So when I tell you, if I have a sound wave
Okay.
travel from one medium to one medium to other medium, so I have one sound wave moved from one medium to another medium, the frequency will change? No, the frequency won't change because the source didn't change. So what will it change? The speed of the
Uh-huh.
wave and also the wavelength, and the frequency will
Uh-huh.
still what? Will stay constant because I didn't change the source. I didn't change the oscillator. The frequency of the wave will be the same. The frequency of the oscillator and the source. There's very, very, very important points when you study waves
Uh-huh.
to know the
Okay, right.
source of
Yeah.
the waves. Where did it come? This is will help you and will make it easy for you when you study this point. So after that, when we talk about
Right. Okay.
so when we talk about frequency, we will directly think about the oscillator, the source of the wave. When we think about the wavelength and the speed, both of them will change according to the medium. If the medium didn't change,
Hmm.
the speed won't change. So, for example, I have a very, very loud voice and very, very small voice, a voice of
Yeah.
a sound of the lion and the sound of a small bear. Which one of them will be faster? The sound of the lion will be faster, or the sound of the bird, the small bird, will be faster? Of course, both of them the same
At
speed. Most of students
same speed. Yeah.
answer have a and a common mistake here. They think the voice of the or the sound of the lion gonna be faster. No. The same medium, the same
Yeah.
speed, the same medium, the same speed. So what about
Uh-huh.
loud voice is loud? That means the amplitude. The voice with high energy, the loud voice have a great amplitude.
Uh-huh.
And the small voice you can't hear it. This is have a low energy and low amplitude. This is the difference. This is
Low
about
amplitude. Right.
amplitude.
Yeah.
Yeah, yeah. Two voices has the same frequency but different amplitudes. And I will draw
Right.
it for
Okay.
you. I when I explain this lesson, I will draw like this. I will draw for you like this. This is what is the difference between these two waves. So I have like this, the
One has
same,
a higher
the
amplitude.
same wavelength, different amplitude. And what about this?
Yeah. Lower wavelength.
This is lower wavelength and shorter in
Higher
yes, lower
amplitude.
wavelength. This is right. Lower. If I put
Yeah.
here like axis, one axis here, the axis be here, and I put here T. Sorry, here I put here T, and here is amplitude. So it will represent the period time
Right.
and the frequency. This is another point, and I must look at the x-axis. Here, x or t. T will give us the period time and the frequency. X will give us the wavelength. I explained this point in detail. How can and you use
Yep.
the graphs and differentiate between the graph between amplitude and the distance traveled and the amplitude and the time. Find a lot of relations. I'm sorry. I'm sorry.
Yep. Right. Yeah.
This is
No
about
problem.
the second
Yeah.
point. Wave characteristics, wavelength, amplitude, frequency. Where did it come from? What will happen if I change the medium? What will happen if I change the resource? And so on. This is very, very important points, and a lot of questions and problems come on it. The wave behavior, reflecting and refracting, and diffract and interference. All of this is very easy,
Yep.
and a lot of
It is
experiments.
right.
I use the same bucket, and also I use a fit a program like this. I will use this
Uh-huh.
simulation, and we will study it in details, and we will make a lot of experiment. I depend also
Uh-huh. Sure.
on my exam, save my exams to answer
Uh-huh.
the previous exams, especially the hard types of exams. I like to solve this type of exams with you
Mhm.
to
Yeah, yeah,
train.
yeah.
I get trains on this type of exams. We solve a lot of them. I prefer
Uh-huh.
to make 60% of the session answering and the training on the exam questions. And I like to move directly to the difficulties. Why?
Yeah, yeah,
Where is your
because once you
okay?
can once you do the
That's
difficult
it.
ones, you'll be able to do the easy ones.
Yeah, this is right. This is right. So